developing new innovations is key to create a real impact for our society. So what do you think about a robot that can help make our daily lives easier? So a robot that has a feeling of touch. So let us welcome now Gael Kloos. He's Director of Innovation at Melexis. He will demonstrate a physical AI-driven robot showing how advanced 3D magnetic force sensors will enable robots to handle fragile objects. So please give him a warm welcome.
Given that robots lack the sense of touch, would you actually trust a robot manipulating a fragile object, such as a plastic cup like this? This is the question that I will address in this talk. At the heart of this question lie a well-known paradox in robotics. On the one hand, robots excel at cognitive tasks. However, in the physical world, they often struggle and can be clumsy. To understand this paradox, we have to look at the foundation of artificial intelligence, the training data. There is an abundance of data available to train for cognitive tasks in the form of text or video. However, for tactile interaction and the sense of touch, we are missing the foundation. We have no data set. So the technical solution would be to cover robots with tactile sensor. But before we do that, we have to ask the fundamental question: how important is tactile sensing? This question was actually addressed by neurosurgeons already in the 1930s, where they mapped the neocortex with the corresponding body part. And they came up with a 2D representation showing essentially how your brain sees your body. And the 3D sculpture really nailed the message that the oversized importance of the hands, especially compared to the other sense. This is in human, but what about in robots? There is a recent study where Bank of America broke down the cost of a humanoid robot in terms of its component, and they came to the same conclusion. Besides the actuator, right after the actuator, the highest value component are the dexterous hand. Our technical concept relies on a mechanical transducer atop the chip package. The transducer consists of a magnet embedded in an elastomer. When a force is applied on the surface, naturally the elastomer deforms, thereby displacing the magnet, modulating the magnetic field. The magnetic field can be then digitalized by a magnetometer chip, which is shown at the bottom, the kind of chip that Melexis is well known for. So this is a good starting point. We have a chip and a sensor concept. However, to make an impact in a new field like robotics, we team up with a robotic research group, Brubotics. We address together a research challenge in rehabilitation robotics: make the robot feel light to the user. To achieve that, we integrated force sensor into a sensorized cuff in order for the user to sense the intention of the user, so that the user can guide the robot with minimum effort. This project was supported by VLIO, which is an organism which fosters collaboration between university and industry here in Flanders. Time for the demo. The demo is conducted by Milan. Milan is a PhD student at Brubotics. Notice that to demonstrate the sensitivity of our sensor, which has been integrated in the gripper, is currently manipulating it using a so-called admittance controller. He can guide the robots almost effortlessly using here the sponge, just to show that we are really, the sensor exhibit here a very high resolution. Now we will grab the cup, the fragile plastic cups. Thanks to the sensor resolution, the grasp will be gentle and will not crush the object. At the same time, the force sensor is actually a 3D force sensor. This is its unique selling point. So we are actually here measuring also the shear force. Therefore, the robot can estimate the weight, which is for the plastic cup when it's empty a few grams. This is operating close to the nose floor of the magnetometer chip, a testament to the good design done by my colleague at Melexis. Now, if we increase the weight, naturally, thanks to the real-time force measurements, the robot can adjust its grasp dynamically. The full-blown demo will be on display in the town hall, where the tactile sensing data has been fused with other modality, vision and audio, to make the system even more autonomous. Thank you, Milan. Thank you for your attention.